Hello, everyone. My name is Mark Freeman, coming from a company called Gable AI. And talk about serendipity. My talk got moved to right now, and it's actually on data contracts. So seeing that slide pop up was a happy accident. Awesome. We need to connect later because I would love to learn more about what you're doing. My talk today is called Shadow Dependencies and the Rising Role Risk of Data. And this is the early preview of our upcoming O'Reilly book titled Data Contracts. So I'm very deep into this subject. Spent the past 3, 4 years really diving in, trying to solve this problem. But what exactly is that problem? And before I go into that, this is the agenda for today. I'll talk about my data engineering villain arc, perception gaps between software and data teams, the huge problem of shadow dependencies and change management. And then I have a case studies of 3 outages, and we're actually going to look at the postmortem's root cause analysis to see how it ties back to data. And then finally go into data contracts. So this is my data engineering villain arc. So I'm not an SRE at all or a software engineer. I'm a data engineer. And before that, I was a data analyst, data scientist. So I've been in the data life cycle. But typically, this was been my life in startups. Hired as a data scientist to build all the cool machine learning. This is before LLMs. So that's a whole different thing now. But the reality is when I get there, build it, and you look at the data, and it's like a huge dumpster fire. There's no way to understand how it's connected, what's the data I should be using. And so I was going to be in a startup. I'm just going to build the info myself. I'm going to fix all these issues so I can build those tools. What ended up happening was they were like, hey, you're pretty good at that. You're going to stay a data engineer. It turns out I liked it more. I like data cleaning more than building models. And so this led to the following questions in my career that kind of sent me on this path to exploring data contracts. Essentially, why is there such a huge disconnect between software engineers and data teams in respect to how data is used? I was told having all this data easily available to me in a data lake replicated over was a good thing for me, but it was not matching my experience. Going back to that image right there, that was the data lake. And is the above problems in just in the company I was at because I was at a startup or maybe just we're incompetent maybe? Actually, no, the whole industry is struggling with this. And so the next thing became, how do I fix this problem? And where this really thrusted me into was, how do I become a translator between upstream software teams and downstream data teams? And essentially they're working with the same data, but in completely different contexts. And that has interesting kind of impact. So where that kind of goes into is perception gaps between software and data teams. This is my life when I was a data scientist. I don't know if any of you have implemented ML models, but the typical kind of joke is that a data scientist will give you a notebook with no proper engineering, and they give it to the engineer. We're like, cool, make it a product. That did not make the engineers happy, right? And rightfully because it's so hard to maintain that. And where I think this kind of big split in infrastructure or in worldviews is OLTP and OLAP. OLTP, online transactional processing, and then OLAP, online analytical processing. And so typically what you have is when a company is building out its data infrastructure and its data maturity cycle over time, you start with a transactional database because that powers your application, that powers the business. That is the most critical thing. But eventually you start asking questions like, hey, what happened to the past? Can we predict something in the future? How should we aggregate this? The transactional database is set up for quick CRUD operations and maintaining state. If I do an analytical query, that's high memory, high scans, and that's going to bring the application down, and you're going to have a lot of unhappy engineers. And so that's why you replicate the data. You increase the complexity by replication with the trade-off that you're able to learn more about the data, about the past without breaking your systems, right? But again, same data modeled in completely different ways. And we'll dive into this. And this is a high-level architecture diagram of what a typical kind of data architecture, very abstracted and very simplified, right? But what these letters represent are essentially the areas in which data transfers and can change and break and cause these major outages within that. And where I've been really focused on is specifically in this area right here between the transactional and analytical place. How do we make the data that's ingested or created with code as reliable as possible? So when it's replicated, you don't have to do all these extra steps for cleaning or added business logic that will eventually break. And so what's the driving force behind this difference? Maybe a quick raise of hands. Who has heard of Conway's Law? Cool. Yeah, it's pretty popular. What about Dunbar's number? Cool. I'll start with Dunbar's number then. So if you've been in startups, there's a magical number where things just blow up. And it's when you pass 150 employees. for a team or for an entire org. And it's been validated in like military, top companies. They have a whole bunch of case studies on that. But essentially is your brain cannot manage multiple relationships. And 150 is that number where there's an exponential amount of relationships that you can't handle. Conway's law is basically how you communicate and how your team is structured reflects in the systems you build. And so if your team is scaling, your systems are scaling, you have a recipe for disaster for your communication breakdown and therefore your production systems. And one of my favorite authors is Martin Fowler, and he has a great article on Conway's law. And this quote, I think, best summarizes it. I read this and I was like, instantly, got to put it in my book. If I can talk easily to the author of some code, then it's easier for me to build up a rich understanding of that code. This makes it easier for my code to interact and thus be coupled to that code, not just in terms of explicit function calls, but also in the implicit shared assumptions and way of thinking about the problem domain. And that last sentence is where the data teams live, is really teasing out what that domain is and what you do with that. And so the root of all this, it comes down to change management. And I think change management is a really solved problem on the software side. You have Git and GitHub. That is one of the ultimate change management tools. On the data side, we really don't have that. And that's what we're trying to figure out how we can implement that and bring those software best practices to the data side, but also highlight how data can be really important to the software team now that AI is really becoming more important. Maybe who was here for the first talk talking about AI agents? That was fascinating. What I really liked about that was they were working with data products, but they're hitting all the errors that I face as a data person from a software context. And so I can see that translation, that empathy bridge starting to form. And so I've been really excited with AI agents. There's a lot of hype around it, but also it's been a forcing function for both sides to start understanding each other better. And so the problem that really comes about these kind of market forces and just the way companies and people organize themselves when building technology, I call it shadow dependencies and change management. And so something we do at Gable is we focus on understanding how your code in a repo connects all together and data flows through those function calls and then connect to a data asset. And so when you talk to a lot of teams, they think their data dependencies or their software dependencies are something like this. Hey, I understand what's happening to our services. It's pretty straightforward. This is the reality when we actually go and scan it. It's much more complicated. That red box, I just zoomed out. And these images are actually real scans we've done on production repos. And so you can see it is much more complicated. And I think anyone could look at this and be like, I have no idea how to navigate this. And there are a few companies that are actually manually going through this. Highly regulated, large enterprise, they have an audit trail. They have to manually do this, right? That costs millions of dollars, hundreds of engineering hours. It's very painful. But if you don't have that regulatory need where you'd be slapped with millions of dollars, you're not gonna deal with that. And so now you have all these hidden kind of dependencies that pop up that can wreak havoc on your system. And going a little bit deeper, what do those nodes actually look like? I'm not going to show you a pretty graph for that. Is you get the source code flow graph. Where are the function calls? How data flows into that? And eventually it will tie to a database or data asset. And then there's the downstream side. And so again, going back to that thought process of this is the same data, same processes, but used in completely different ways. Software teams, they live in this world. Data teams, they live in this world, right? And they don't know how to communicate their requirements to each other. And so how do we fix that? And so this is talking to for researching the book and also just like helping implement data contracts at companies. We talked to hundreds of engineers. And this is like the main things we learned is we tell them, hey, do you know, we talked to your data team, this service, they pull that data and they feed into a machine learning model that powers like millions of dollars for the company. Did you know that? And they're like, what are you talking about? Are you serious? We never agreed to that, right? Countless times we talked to engineering teams who made data available, trying to be good stewards, right? And they had agreements between their consumers that they knew they were going to be there. But again, the data's thrown into the data lake and data people downstream are sifting through, hey, what's valuable? What can I find? And they just start pulling data into there. And the POC becomes something that's production. The production thing becomes actually valuable to the business. And now it's actually a hard business requirement, but everyone upstream completely unaware of that. And I think that's not like an ideal working relationship because if they knew that was important, they would want to know and they wanted to account for that, right? And so just to get out of the theory, this, and something I want to make very clear, I come from the data engineering side, not the SRE side. So this is me trying to like translate kind of your world into how I see it from a data lens, right? But I would love to talk to y'all afterwards, see what your SRE lens is for this and see how we can translate that. And so here's a common pattern of failure that I've seen looking at root cause analysis and postmortems. There's large complex systems with lots of dependencies. Siloed teams are not fully aware of the blast radius of a bad change, and changes in output results is mismatch expectations. And so one of the first examples was the recent Google Cloud outage. Essentially, there was a policy data that contained unintended blank fields. So nullness is or missingness is something that data folks are obsessed with, right? This was pulled into subsequent areas for, I think it's called spanners. Again, not in that now world, but essentially replicate across all of Google's cloud services. And what ended up happening was people couldn't log in. And so you had a data change that seemed very minor, missing this, resulting in a large portion of the internet unable to log in to there. Another one that's classic is CrowdStrike. Again, they do security. They're implemented on a lot of machines for airports, a lot of utility services, very highly sensitive things. Similar thing. They had this capability predefined set fields for a rapid response content. And so what the rapid response content does is, hey, how can we quickly identify new security threats live and implement that? They changed the schema of what was expected. They expected 20 fields, but the updated one provided 21 fields. Again, small data change also resulted in the whole thing crashing, causing blue screens of death across these infrastructure critical systems. And then finally, it's more kind of a data focus is Lock2 Cloud is an authorization tool. And they did a simple schema change. They essentially changed the schema for a database. They deployed that. They had a requirements change happen where they had to do the second deploy was a little bit later with the actual API change. And so they were disconnected and now their whole system went down, right? And what I like about the Log2 Cloud and why I want to include them is they're public open source. And so you actually see the code that caused the break, which I think is pretty cool. And you look, it's a SQL file. They changed the value in the database. And it's going a little bit further back. Those are those kind of real world examples. Again, same data represented in different worldviews. This is what the software engineers see. They have their configuration file. This is just like a pseudocode config files, right? Software engineers see the config. That's the world they live with and deal with. Data engineers, they see the data movement between systems. So they're going to see in JSON, wherever kind of data format. And then downstream, the analysts, they're going to see it as a table. Again, same data, but again, in different views, different purposes. And so the question becomes, whose purpose is correct? Under what context? And that's that change management component. And so again, going back to those common patterns, large complex systems, the way you resolve for that is automatically map dependencies in code. Talk about static code analysis. That was that diagram I showed you, creating those lineage. Silo teams not fully aware of the blast radius of a data change. Again, you map out data ownership to the code changes. And so everyone has their own domains. You can tie like, hey, this person made this code change. Here's this tag of this user on GitHub. This person's part of this team, right? There's some really interesting metadata that you can capture and do some very fascinating things with automation. And then change output results in mismatch expectations. You check the expectations against the code diff, and this is what data contracts are, which we'll talk about further. And this fits within the CI/CD process. So solution, data contracts. The way we define data contracts in our book is they are a data architecture pattern that extends software-driven collaboration to data teams via API-like agreement that programmatically tracks and enforces expectations around data within the CI/CD workflow. And it was awesome. The previous talk, they actually had a data contract spec, and I actually removed that from my talk. So that was actually cool to see that up there. And this is what that flow looks like at a high level. This is also from the book, and this is coming from the consumer side. So step one, a data constraint is identified by the data consumer, saying like, hey, we have this domain need for the business. The data needs to be this shape that has this kind of purpose for it. They request a data contract, which is typically a YAML file. And last talk, they showed, hey, here's my expectations for the data. This should be a string, or maybe it should be enum with these specific values. The data producer then confirms that the contract is viable, and then they commit that. So now your expectations are now version controlled and it has a history of that. So now move forward. Say, for instance, this data producer, say a software engineer, they got a way better job. They're going off and now they work for like OpenAI and make $1 million. Now we have a new engineer coming in, no context at all. They're just like, hey, I'm gonna be valuable. I'm just gonna make a change. They can make a change and without even being aware, because the expectations are saved as code. It goes through a CI/CD check, and then if it says, "Hey, are you changing a code that impacts data asset under contract? If so, are you breaking a violation? If not, cool, pass, merge the code. If you fail, alert the data asset owners who have the domain context into that PR so you can actually have that conversation right away. And we have fail tiering. Sometimes a change is valid. You want that change to happen and you want to communicate that across the business to your consumers, right? So maybe you'll have a soft failure where like, hey, we'll change this. You're just gonna be notified. Or it's business critical. You have again, maybe it's tied to a recommender system that's very important to the business. Heart failure, you absolutely cannot do that, right? This is basically table stakes. We folks on the software side, on the data side, it's a little bit pulling teeth for them to see this kind of worldview. And so we're at the building blocks data contracts. You have data assets, so you have the various databases, the code itself, and things along those lines. You have the contract definition, which is that contract spec, which is like a YAML file. I'll provide a quick example of that. And this is what most of this talk is around, is the detection. And this is what separates early implementations of data contracts and advanced applications data contracts. It's very easy to put that check in the CI/CD. You can do like a heuristic. What gets really much more complicated is how do you get much richer metadata and signals throughout your business, throughout your software systems? And that's when you start getting into static code analysis. That's when you start using LLMs to pull out context, whole bunch of other things. Maybe you create a graph database to traverse things, right? And then finally, the prevention, which is CI/CD monitoring alerts. This is very much in the SRE wheelhouse on that side. And so for the workflow, this is what it looks like. Say, for instance, you're in GitHub, you're making a change, you push a commit to your branch, it pulls it up in Docker, and then you pull up the database and expect a schema. And then for this example, we're using a streaming service. So we have a schema registry. Think of it like data catalog. What's the metadata for XYZ? Does it match your expectations? Yes or no? For this example, no. And so it's going to block the build. And here's the example of a data contract. Hopefully you can see that. Again, YAML-based file. And on the right side, this is an example of what a violation looks like within the pull request. And again, one of the biggest complaints when I first started diving into this was, wow, this sounds really cool and useful, but it sounds very theoretical. Who's actually applying this? And so one of the biggest things I wanted for the book was to actually have a sandbox repo. So you can actually go to this public repo, and I have a QR code for that, spin it up in the browser, and you can break a database and see how a contract can protect it for there. And some closing thoughts for this. Data and software teams have been historically isolated, but the rise of data products, and specifically, I think AI, has been creating increased dependencies where the data teams and the software teams are really collaborating a lot more, or at least experiencing pain points they haven't experienced in their own domains, but the other has. One company we talked to, they're implementing LLMs and agents along with a lot of other companies. But one of the key questions they had was, is it our model that's wrong, or is it the data that was wrong? And that distinction is actually very hard to do without data contracts or some type of auditing and checks in place. And those are two different problems to solve, right? For that. This divide ultimately results in data producers, such as software engineers, being completely unaware of the data being used for business critical work. Again, data is becoming more and more important as no longer just random dashboards for the execs. It's actually driving revenue. And so the root of this problem is change management and communication. A lot of this, if you're in a small startup, a lot of this really doesn't apply. You can just go over to the desk over there and say, hey, you broke this thing for me. What's happening? What's the context? But if you go into an enterprise, you can be different teams, different buildings, maybe even different countries, right? And so that communication between all sides is just substantially more difficult. And my co-author is actually here in the back for this. Something I want to highlight is that this all sounds nice, but how do you convince these other stakeholders who don't really own the data traditionally to care about this? And something my co-author always says is that for this behavior change, you need to automate as much as possible to make the adoption simple for them to engage in this. So that was another quote from the previous talk that I really aligned with. And then finally, data contracts leverage the power of Conway's law to optimize communication among relevant parties within complex systems, especially at scale when Dunbar's number, 150 employees, is at impact. And again, shout out to my employer for sponsoring me, for allowing to be here. This is just a quick high level of what we do at Gable. We scan code, understand the dependency graph between all of it, connect it to data, And we use complex machine learning models to actually understand what that change would do to the wider system. Thank you. I think I have about 5 minutes left for questions here. But here are the QR codes. You can actually download the early release of the book. It's coming out in November. So very soon. My life's been very busy with this book. So you can do a free download there. And then also that public repo where you can actually say, hey, I actually want to get my hands dirty and actually code with this. That's free and open to anyone. You use code spaces. So you just go there, click a button, and Docker is all set up for you in the browser. You can go break some things. Thank you for your time. And I guess maybe last 5 minutes for questions. Yes.
Okay. This is cool. I love what you're doing. I've seen people working in this area for years. I see lots of tools and talks and ideas. What's anybody built on top of this? Is there any application we can look at that's been successful that shows that data contracts is something somebody can build a real application with, or are they all proprietary things that we don't get to?
Yeah. One of the things is I think a really great case study is Glassdoor. They actually implemented both static code analysis and data contracts. And so for a high level, is actually one of the case studies in the book. So I can actually go into that a little bit. Is essentially what Glassdoor does is they sell ads to companies for their job postings, right? And so for the data component, an impression on an ad basically counts as revenue. And so if they miscount that, they're losing revenue for that. So that data needs to be very accurate for that. They've been building multiple systems over time and doing a bunch of migrations. The company's multiple decades old. And so understanding what brand events, that's what they call it, brand events, for the ads, what events actually existed within the system, they actually had no idea because there's so many migrations and tech debt over time. And so they use static code analysis to actually map out all where those connections were, able to clean up their code base to remove unneeded kind of events. And then also ensuring that with data contracts, if there was a violation, they used Kafka, so event streams. So it didn't match the data contract. They had a dead letter queue. So that bad data would never reach their database system. And then in addition, any changes to those events that were critical to the calculating the revenue, they would block any negative changes for that with the data contracts. They have, if you look up on Glassdoor's blog, it's like Glassdoor scaling to petabyte scale. But yeah, look up Glassdoor data contracts. It's on the engineering blog. Yeah. Any other questions?
So in your experience, at what level these companies are applying the solution? At a line of business level or enterprise-wide?
That is such a good question. I should have been speaking closer to this. Sorry if you didn't hear me, but it's a yes and all of the above, right? So where this problem, again, think about Dunbar's number, has to be scale. Enterprises are the ones that are actually implementing this. But if you worked in an enterprise, I've been in startups, but I've been exposed to enterprise and helping them try to adopt these things. They can't just implement it wide. You have to show success with a very small use case. In the book, we call them steel threads, where you're like, hey, what is one of the most important data assets you have within the business that's constantly failing that you can point to and say, we can fix this? You do that first, right? But then I think where a lot of people make mistakes at when trying to expand data contracts, like, hey, we found success with this. Other people find success too. Actually, it goes beyond a technical problem. It's a socio-technical problem. You need to do a lot of culture change work. You need to change who's the ownership of data. When data goes down, is it tied to code? It's not just the data team's problem, right? It's going across multiple different teams. Multiple different teams might have different objectives, right? And so in the perfect world where everyone's super aligned, yes, wide enterprise. The reality is getting adoption across enterprise is much more like political and takes years, and it takes a huge cultural change effort. And so that's why I'm seeing, again, large enterprises and specifically high regulatory need being a catalyst to drive that, because they're already doing this anyways. It's great that it's now automated for them. Does that answer your question? Yep. I have 10 seconds left here, so I'll maybe just pause here if you have additional questions, just come grab me. I'm happy to chat or add me on LinkedIn. Happy to chat there too.
Thank you, Mark.
Yep. Thank you.